Students, in the previous video session, we have gone through the macroscopic understanding of various states of matter, and we have seen the introduction part of the 7th unit about the properties of matter. Let us see the elastic behavior of the materials. Here you can see a rubber band. We know that this rubber band having elasticity property. So if you are applying a force like this on rubber band, what will happen to this rubber band? Yes, we know that this rubber band will get a stretch when we apply the force on this rubber band. Once we remove this force, what will happen? This rubber band again it will regain its original shape and size when we remove the force. This is what happening, and you also know that if we are taking a rubber band and we are applying a stretching force or deforming force on this rubber band, you can see that the rubber band will get stretched. Once you leave, you can see that it will regain its original position. So now what is happening here? So when we are applying the deforming force on this body, what happened means its atoms are pulled apart. You know that in this rubber band it consisting of many atoms. So when we are applying a deforming force on this rubber band, here you can see the solid how the atoms are arranged, and here also you can see this type of arrangement will be there. So when we are applying the deforming force, what will happen means these atoms are pulled apart. So here you can see that the interatomic distance between this is very less. So when we are applying the force on this, what will happen means this interatomic force of force will get what? Interatomic distance will get more. So the time what will happen means these atoms are pulled apart, or if you are leaving that deforming force, we can see that the atoms again it is coming closer, or you can tell that it is pushed closer. Now the same thing happening when we are removing the deforming force also. When we are removing the deforming force also, what is happening? The interatomic force of attraction or repulsion restoring the atoms to their equilibrium position. So the thing is, what I said means when you are applying the deforming force on this rubber band, it stretch and what will happen? The atoms pulled apart. When you are leaving this force, what will happen? Deforming force, the time that atoms are pushed closer. So you can tell that this body is regaining its original shape and size once we remove the deforming force also. So if the deforming force is removed, when we remove the deforming force, so that the object is regaining its original size and shape, means you can tell that it is elastic, and that property we can tell elasticity. And the force we are applying to change the size or shape of a body, we can tell that deforming force. So all understand what is elastic and what is elasticity and what is deforming force. Again you can see that elastic means what? If a body regain its original shape and size after the removal of deforming force, it is said to be elastic, and the property is called elasticity. And we are applying some force to change the size and shape of this body, that we can tell deforming force. So this is a property of the elasticity. So elasticity means you can see that it will regain its original size and shape if we are leaving the deforming force. So remember it. So next you can see is plasticity. Actually we know that the plastic object, if you are applying the force on the plastic object, it will get a break. So but the rubber band it can stretch, and we are leaving that deforming phase. You can see that it is coming closer, it is regaining its original size and shape. But the plasticity means what? If you are, we know that the plastic object, if you are taking a plastic object and we are applying a deforming force, or we are stretching, or we are compressing that plastic material. For example, you can see this is a plastic material. So if I am applying a force on this, suppose a deforming force, I am pressing this too much, we know that it will get a break. So it will not it will not regain its original size and shape. So such object you can tell what plastic, and that property you can tell plasticity. So what is plasticity means? Here you can see, if a body not regain its original shape and size after removal of the deforming force, it is said to be plastic body, and the property is called what? Plasticity. So you can see example glass and some other material, plastic material. So glass property also we know that if you are applying a force on that, it will get a break only. Again, it will not regain its original shape and size. So next thing you can see is stress and strain. Actually, what is this stress and strain? First thing, stress. Assume that you are applying a force on a object. So when we are applying the force on the object, we know that their size and shape both will change, and it is changing because of the relative position of the atom is changing. So stress means what? Assume that you are applying a force on a body. So when you are applying the force on the body, we know that their size and shape is changing. Its size and shape is changing. Why this size and shape is changing? Its size and shape is changing because its atom position is changing. The relative position of the atom or molecule is changing. And we know that this is noticeable in some of the object with our naked eye also. So you know that so during this time, it is, I said that it is noticeable with our naked eye also, and we can see that such a deforming force during this time, what is happening means some internal force is developed, or you can tell that some restoring force is developed, and this force per unit area we can tell stress. So for example, if you are seeing that we know that sometimes assume that you are holding a cup of water in your hand. You are holding a cup of water in your hand, and assume that that cup of water you are holding straight like this for long time. So you are holding that cup of water by keeping your hand straight for a long time. So we know that we will get on pain on our shoulder part. So that is what we can tell, that the internal force is developed on our shoulder, and this force is acting per small area. That is what we can tell stress. And stress equation you can write sigma is equal to force by area, F by A, and SI unit you can use is N Newton meter power minus 2, or you can use Pascal. Pascal symbol is PA, and this is what stress. So stress means what? The force per unit area is called stress. So sigma is equal to force by area, or is equal to F by A. Unit is Newton meter power minus 2, or you can use Pascal. And if you are remembering the stress, the word stress, you can see that so some internal force is acting. When that internal force is acting, so when we are applying the force on some bodies, we know that that body, their atom, because of the atom changing its position, the relative position of the atom or the molecule is changing. So that what is happening means there is an internal force is creating. So that internal force, or you can tell that a restoring force, and this force is acting per unit area. That is what we can tell stress. Now there are some types of stress. You can see longitudinal stress, tensile stress, longitudinal stress, tensile stress, compressive stress, and volume stress. And let us see the longitudinal stress. Here you can see one object, and on this object from different part the force is applied. So when you are applying the force on this object from different position, you can see this center of mass is what remains at rest on this object. So what happened means this body is getting deforming because of the forces applied. So here what is happening means there is an internal force is appearing, and that force is acting in different direction, so that it is resolving into two components, Ft and Fn. And Ft means it is a tangential force, and Fn means the normal force. So this normal stress or longitudinal stress over an area, you can tell this is what normal stress or longitudinal stress over an area is defined as sigma n is equal to Fn divided by delta A. So the stress means we know force per unit area. Here also force is acting a small area. So here normal force is acting on an area, so you can tell that is normal stress. And tangential stress means tangential force is acting on an area, so that is what the tangential stress. So if you are seeing that example for this longitudinal stress, let us see. Assume that you have a paper, and you have paper like this, and you are cutting by scissor like this. You are using a scissor to cut this paper. So when we are applying the force on this area, what happened means you can see that the scissor will act a force on downward direction from this part. So the force will act downward, and the other side of the scissor will act a force upward. So because of these two force, what happened means the paper is getting cut. So here to cut this paper, this both force, you see here the upward force and the downward force is acting on this changing area. When we are cutting this area also changing, and so that we can tell it is longitudinal stress, or we can tell that a tangential stress. Now the tensile stress means, you see here you can see one object. On this object forces are acting from different direction. From this side also force is acting one side, and here the force is acting another side. Now there is a stress producing, that is what we can tell tensile stress. If you are seeing that example, you can see that the insulation tape, maybe you have played like this. So if you are taking an insulation tape, like this insulation tape is there. So on this insulation tape, you are applying a force this side and this side. So when you are applying the force on both sides, you can see that the insulation tape will get change its area like this, isn't it? So during this time, one stress is producing here, and this is what we are saying tensile stress. And next one is compressive stress. Compressive stress, assume that you have a center fresh bubble gum. You have a center fresh bubble gum, and from on this both side you are pressing this both side of this bubble gum. So what will happen, this area will get a change, and during this time on this bubble gum on stress is producing, and this we can tell that compressive stress. Now you can see the force which is acting from both sides, from equal and opposite direction. The force is acting on the object. Now there is a stress producing, and this is what we are saying, compressive stress. So you can see here, you see the forces acting on the two sides and push each other. So what is happening, delta E is pushed by equal and opposite by 2, and now this object is under compression, and this time on stress is producing, and this is what we can tell compressive stress. The next one is volume stress. So if you are saying about the volume stress, assume that you are imaging an object inside a fluid. Assume that you have a cup or something, and you are imaging that cup inside the water tank with full of water, so that you can see that when we are imaging the cup inside the water, you can see that there is a pressure producing at that area. There is a pressure producing on that small area, and due to this pressure there is a stress producing, and that is what we can tell volume stress. So the force per unit area is called volume stress, the same definition only. So sigma V is equal to F by V. So the same thing only what I said. You see, when a body is acted by forces everywhere on the surface, such that the force at any point is normal to the surface. And here what happened means, when a solid is immersed in a fluid, the pressure at the location of the solid is P. So the force on any area F is equal to P delta A, and this force is acting perpendicular to the area, and that force per unit area is called volume stress, you can tell. And you have to learn the definition for stress and strain. That is very, very important. So this is what about the stress. So you can see that so first thing, stress means what? So stress means force per unit area. Sigma is equal to force by area, and SI unit of the stress is Newton meter power minus 2, and or you can use Pascal, and the dimensional formula is ml power minus 1 T power minus 2. Next you can see there are some types of stress. In that, first one is longitudinal stress, and then is tensile stress and compressive stress. So longitudinal stress means sigma n is equal to F1 by delta A. Tensile stress means, tangential stress means sigma T is equal to Ft by delta A. And you remember this thing. So here this body is getting deep forming due to the forces acting on it. So there is an internal force is appearing. Due to that there is a stress produced, and that is what longitudinal stress. And tensile stress, you can keep this example, insulation tape you are pulling from both sides, so you can see that tensile stress producing when it is touched. And you can see that compressive stress, you can keep this example, bubble gum. You see, when we are applying the force from both sides, from equal and opposite direction, we can see that there is a change in shape of this, and it will get compressed, and due to this stress is producing, and that is what we are saying compressive stress. And next one is about the volume stress. Then we can see that strain. And here we have seen about the stress, and strain means, and it is a measure of this stress only. And strain means we can measure how much an object is stretched or deformed when a force is applied. So when you are applying the force on a body, how much the object get stretched, or how much the object get deformed. So when you are assume that you have here the same example, so you can see that on water bottle is there, you are applying the force on that water bottle. So when you are applying that the force on that water bottle, we know that that water bottle will get compressed. So during this time, how much that object is you can tell that deformed or stretched up. So when we apply the force, that measurement is what we are seeing, it is strain. And you can definition wise you can tell strain epsilon is equal to change in size divided by original size. So you can define it is the fractional change in, you can see fractional change in size of the object, or you can define it is a measure the degree of deformation, measure the degree of deformation, and study this formula delta L by L. So strain means what? The fractional change in the size of the object, or strain measures the degree of deformation, and strain epsilon is equal to change in size divided by original size, so delta L by L. Next one is in the strain also there are some types: longitudinal strain, tensile strain, and compressive strain, shearing strain, volume strain. In that, the first one is longitudinal strain. So longitudinal strain means what? Assume that you have a rod, you have a uniform rod, on rod is there like this. So on this rod you are pulling from both sides, you are applying more force and pulling this rod from both sides, so that you can see that this length will get maybe increase. So when you are making the knife and all, maybe we used to give a small plate, and what they will do, they will beat this object, and this size will get increase. Now there is an increase in length of this rod while making the knife and all. So during this time one strain is producing, and strain, that is what we can tell longitudinal strain. And the formula you can see, epsilon L is equal to increase in length of the rod divided by natural length of the rod, delta L by L. And this longitudinal strain can be classified into two types: tensile strain and compressive strain. If the length is increased from the natural length, so when you are applying the force on a body, if the length is increased from its original length, so you can tell it is tensile strain. And compressive strain means if the length is decreased from the natural length. For example, you know that rubber band, if you are applying the force, its length will increase. So you can tell that that is tensile strain. And the compressive strain, that rubber band, again, if you are taking a spring and we are pressing like this, we can see that the spring will get compressed, and it is reducing its length from its original length, so that you can tell compressive strain. And the next one is you can see that shearing strain. And shearing strain, here on example is given. Here you can see on cuboid, and assume that this cuboid is in its translational and rotational equilibrium. Now there is a tangential force is applied on this object. Now it is getting deformed. You can see this cuboid deforms, and so you can explain shearing strain is called A dash divided by BA. A dash, this much deformed, so A dash by BA. So you can take this formula, epsilon s is equal to A dash by BA is equal to x by h or equal to tan theta. So here from this triangle, A dash, B. From this triangle we are taking tan theta. Tan theta means we know that opposite side by adjacent side. So we are taking opposite side. This is the theta, this is opposite side A dash, and adjacent side is BA. So x by h we will get and we can consider this angle is very small, so you can neglect this angle, so that you can write theta is equal to x by h, and this is what we can tell angle of shear. Now volume strain, the last one is volume strain. Assume that if an object is, you are applying the force on the object, so if assume that its volume is getting changed. So if the volume is changed, we know that some stress is producing in that. Now because of this there is a change in volume. So when we are applying a force on that, so there is a change in volume on that object. So that is what we can tell volume stress. So before this, what is happening means its volume is changing, so that we are measuring by using volume strain, and this volume strain epsilon v is equal to delta v by v we can tell. And the last one is elastic limit. Elastic limit means nothing, so we know that maximum stress within which the body regain its original size and shape after the force we removed. So assume that you are applying the force on the rubber band. So when we are applying the force on the rubber band, we know that it is stretched. So if you are leaving that, it is regaining its original position. So if that object is regaining its original position and shape, that is what we can tell elastic limit. That point we can tell elastic limit. So my dear students, all of you go through this stress definition, strain definition, and elastic limit definition, and all these formula. Thank you all. See you all on next class. Bye bye.